Hi, my name is Nicholas, and today I'm gonna talk about dielectric materials. Capacitors plays a huge role in our life. It is used everywhere as it is perfect for an energy storage system. The simplest type of capacitor, a parallel capacitor, is separated by an insulator, which is a dielectric material. When the capacitor is connected to a battery, the plates can store charges. The negative and positive charges are attracted to the opposite terminals, but then it will be repelled by their own terminals. This makes one plate being negative charge while the other one is a positive charge. The charges on the both sides will be balanced, and even if the battery is removed, the charges will stay as it is trapped inside in there. Now each individual capacitors have different amount of charges. This is called a capacitance. It is the ratio of charge Q of one plate and the potential difference between the two plates V. So it goes by this formula.
We can also use this triangular pyramid to find the potential difference and charge. The LRC meter is the tool used to find the capacitance.
There are a lot of factors that affect the capacitance of a capacitor, such as surface area of plates. The bigger the surface area, then the greater the capacitance will be. The distance between the plates. The closer the distance between the two plates, then the greater the capacitance will be. And finally, the dielectric material being used. The dielectric material used may affect the capacitance. It is because every type of dielectric material has a different constant, K, where K is the ratio of permittivity of a material to the permittivity of free space.
Based on the formula of dielectric constant, the value of permittivity of free space will always be greater or equal to permittivity of the substance. This is why the dielectric constant is always equal or greater than 1. The problem with capacitors is that if too much electricity is given, then the electric field will be bigger. Bigger electric fields may lead to a short circuit in the capacitor. This happens because the dielectric material cannot contain more than its breakdown field strength. That is why we are using the dielectric permittivity as a foundation for measuring the electrical field to decide how much electricity will be used. Lots of dielectric material are usually made of plastic, metals, and electrochemicals. The cheapest ones are usually made of plastic or mica, where it comes from fuel, a non-renewable source. So why don't we use another alternative which comes from natural resources? I'm thinking about using rubber, because in Indonesia, rubber is a very common resource and it's also a good insulator, with a high permittivity of 7. Natural rubber has advantages such as good elasticity, breaking stress, tear resistance, and abrasion resistance. But for the uses outside the home, natural rubber is not resistant to weathering or ozone and aging. Heating at high temperatures results in a decrease in the mechanical properties due to the breaking of double bonds and the formation of free radicals. Natural rubber is widely used for the manufacture of engineering goods, especially rubber products which are used at temperatures around 100 degrees Celsius. The use of natural rubber needs to be mixed with synthetic rubber, which is a heat-resistant and weather-resistant rubber. As we can see in this table, Indonesia is the top 2 producers and exporters of natural rubbers. With this much resources, it can be used to help the problem with capacitors as a better alternative material for dielectrics. So with all this, I hope that resources such as plastic can be used less, as it is a non-renewable resources, which is bad for the environment. And instead, we can use the rubber alternative, which is a cheap and a renewable source.